Welcome back, geologists, and we're here for the second half of the age of the insects of the Pennsylvanian period. So you're fixing to discover what this massive creature is right here and learn a little bit about some of the famous animals and plants and reptiles and amphibians of the Pennsylvanian. So let's get started. Of course, Fusilinids need to be discussed. We start really seeing Fusilinids heavily in the late Paleozoic, and they are an extinct class of Foraminifera found in rocks that are Pennsylvanian and early Permian in age, which makes them excellent index fossils for the late Paleozoic, specifically the tail end of it being Pennsylvanian and early Permian. They are usually pinhead size, but they can get up to 2 inches in length. And some of the really big ones are found in Texas, which is an interesting occurrence considering we have a huge amount of them in the Permian Basin. They develop a shell, an outer casing called a test, which it's made out of calcium materials that's extracted from the ocean. And we do find huge quantities of these in any kind of marine rocks that exist from the Pennsylvanian. This is a series of Fusilinids that are late Paleozoic. They almost look like little footballs to me, but they are so small when you pick them up, they're just like grains of rice almost. They're very tiny, but they did get fairly large, up to, just a couple of inches big in length, and that's pretty large for a single-celled organism. Here's some more Fusilinids that are common, a dime's there for size comparison, so you'll have a reference of scale. So the age of the insects really needs to be talked about from a perspective of climate. The climate changed. We had an oxygen-enriched environment, so your discussions will need to emphasize on this, and I've even asked some questions to folks about this very issue. What do you think could have caused such an oxygen-enriched environment? And I'm going to ask you to think about that yourself. If you read your textbook, you may have a couple of clues. But nevertheless, we did. And so as the sea would advance and retreat with small variations, marine life declined, but coal swamps increased. And that's what we have in North America during this time period of Pennsylvania are coal swamps. These swamps had about 35% oxygen. When you consider the concentrations are around 21-ish% today, that's substantially more oxygen in the atmosphere. This high oxygen concentration would allow several things to occur. The first is probably obvious, that plants would radiate quickly in large concentrations, in thickness, and in height. And then in response to the ability to have lots of food, lots of habitat, and limited predators, the insects got enormous. And this is going to be the largest insects that we'll ever see in geologic past. So an interesting development, and let's take a look at some of them. Meganura is one of the most famous of the Pennsylvanian or Carboniferous insects. I would like you to imagine if you could spread your arms and spread them side to your side. On both sides, raise your arms equal to your shoulders and hold them out. And that's about the wingspan of this guy. A very scary insect indeed, a predator on top of that. So I've been riding motorcycles for years, or at least in my prior life I did. And I can't even imagine how bad it would hurt to get hit by one of these in the head, or even with full leather on, what that might have felt like back then. So this is every nightmare for riding on a bicycle or a motorcycle or a convertible for that matter. These guys were the largest flying insects ever known to live on Earth. Dragonflies are really good at what they do, and today they eat mosquitoes, so they would have eaten the bugs and the things flying around in the atmosphere, meaning right by the swamp conditions. So they serve a really good ecological niche. Nevertheless, they were ginormous during the Carboniferous. The arthaplorid is another famous animal. This is a millipede-like organism, 6-footer. How would you like to be walking around the swamps of the Carboniferous and step on one of these guys? Makes me just cringe. This is the largest known terrestrial arthropod to ever have lived on Earth. Now we had the Eurypterids, which were the sea scorpions, but they were ocean creatures. These guys are land dwellers. So they didn't really have any known predators, so they could get enormous eating this incredible amount of green material that was available for them in the swamps of the Carboniferous. Amphibians continued to exist in the swamplands, but their numbers declined as reptiles entered the picture and began to radiate and fill the same niches. We still see that true today. The Hylonumus is the oldest known reptile from the Pennsylvanian. Now, I mentioned the true oldest one that was recently found in late Mississippian aged rock, and there's still a number of scientists that hold this guy as the winner of the prize for the oldest known reptile. But since we really do have fossils of one in the late Mississippian, we need to put it there. Nevertheless, this guy was a small, little bitty lizard-like animal that lived in the hollowed stumps of club mosses and Carboniferous swamps. And he would have fed on small little grubs and insects and plant material that existed in the Carboniferous swamps. Lepidodendron trees are very important plants that grew very tall during the Pennsylvanian. They're referred to as scale trees, and they are a form of lycopsids which existed during the Pennsylvanian. They lacked branches except at the very, very top of the tree, and then they have these cone structures that are there that help them reproduce and germinate. What's important to note are these scars that you see along the stem here. As the tree grew, these leaves would be replaced from the top, leaving this part barren, and it left a set of scars behind. These rows of scars are what make this particular species of tree so infamous, and they have a very distinctive look in the fossil record. Here's an example of a fossil I have of one of these things, and it is rather remarkable if you can see the pattern there. Those are the scars left behind as the leaves moved with the top of the tree. Here's another set of fossils. This particular set are found in the Mesalands Community College. They have a dinosaur museum in Tucumcari, New Mexico, and this is on exhibit there. And matter of fact, they donated the last specimen you saw to this college for us in exchange for some Texas types of fossils that we have. And this is an extraordinary look at this particular fossil. So these were pretty large creatures in terms of being plant life, and they were totally in the coal swamps of the Carboniferous. Sigillaria are an extinct lycopsid that grew as tall, really taller than what we just saw. And there had leaves and roots very similar to our big tree friend we just investigated, but had a rarer branching system and trunks that lacked the scaly pattern. Instead, they kind of had these indentions that looked like little circles that went up and down the trunk of the tree. Their cones occurred in clusters like you see right here, as opposed to the top of the tree that were individually attached to the tips of their branches. So there's a distinctive difference between the two types of trees. This is a Sigillaria fossil right here, and you can see its patterns of indentions. Looks different than our good friend that we just saw a few minutes ago. Synopsids were important coal-forming plants characterized by being jointed, like you see right in here in the fossils, right here and right here. And they had a horizontal underground stem-bearing root system. Calamities is a famous species of this that averaged 25 feet tall. So when you look at these fossils, you'll see their leafy patterns. We have some of these today, but nevertheless, they were very prevalent in the swamps of the Pennsylvanian period. Here's some more of the leafy matter of these plants. Corydeides is another important plant from the Pennsylvanian. Now, these were a bit different. They were gymnosperms that occupied a different environment that was drier and on higher ground, and they grew up to 150 feet tall. So they were important, and they made some of the forests that we see throughout the Pennsylvanian period. Before I even go over the highlights for the Pennsylvanian, I'd like to make a connecting point between the Mississippian and the Pennsylvanian. Connect the dots to how important this period of geologic time really is. If you recall, we separate the Carboniferous because of two distinctive different depositional environments. So the Mississippian was like the Bahamas, and the Pennsylvanian was like the Everglades, a coal swamp. The mechanism by which we had these changes of depositional environments is one of the key parts of understanding the Carboniferous, and that's the glaciation cycles in Gondwana. At the same time, we need to revisit that paleogeographic story from the first part of the Pennsylvanian, where we had considerable mountain building. Incredible size mountains being made and stresses being put on the southern part of our craton, and not to mention the eastern margin with the two big orogenies we had there. And then, of course, with the ancestral Rockies. The Alleghanian orogeny would uplift the Appalachians for the very last time. So what we have left of the Appalachians today, and even the Ozark Mountains for that matter, the uplift of the Ozark Range, which would be the remaining Ouachita Mountains, and then of course what's left of the Appalachians like the Great Smokies, the uplift they've had has been from isostatic rebound in the Cenozoic, not from active continental bombardment. So this will basically conclude the mountain building in the Appalachian, and the remaining story for the rest of our semester will be on the western Cordilleran edge that will experience numerous collisions. So the end of the Pennsylvanian is making a pretty good supercontinent. It's not 100% complete yet. We'll have to get to the Pangea during the Permian, but we're setting the stage for making that happen with the bombardment of South America and Africa to our continent. Not without consequences, though, for the rocks, the sediments, and even for climate. So the difference between our Mississippian and Pennsylvanian is remarkably different than what places like Europe experienced during the same time frame. They just had coal swamps the whole time. We're fortunate enough to have this remarkable rock history that shows the Arb-Soroka Sea at work in our craton, and we've even got this beautiful rock layer in the middle of the Grand Canyon, literally, that you can see in the thickness of this remarkable Epiric Sea that dominated our interior craton. So when you're thinking about the life forms that we just discussed, you're not going to find some of the big insects in Mississippian raised rock. You can't. You didn't have the right depositional environment. They only would have lived in the Pennsylvanian swamps. Now you can find them corresponding for Mississippian age in other places of the world like Europe, where we had Carboniferous swamps for the entire duration of the Carboniferous. But I wanted to make that connection because the Carboniferous is famous for the coal and for the big insects, but none of that would have happened had we not had a rise and fall in sea level repetitively, like up to 50 times during that Carboniferous time period. So when you look at the overall storyboard for the Pennsylvanian, I want you to think about these highlights. The age of the insects is just the cake, the icing to this remarkable time period. Really, if you had to choose anything that was so significant besides the development of cyclothems, it would be the massive amount of mountain building on the west, on the east, and on the south margins of our craton. It was a time of rocking and rolling for the North American craton in terms of having crustal deformation. So the various different trees we learned about for swamps, and then the non-swamp tree we learned about that made the forest, and the big animals in terms of insects that we learned about, they're going to transition out after the early Permian period when conditions change again as Pangea starts to fully assemble and climate shifts. So let's take a break from all of this and realize that we didn't have a mass extinction at the end of the Pennsylvanian, but we're going to see something change as we enter into the Permian. So take a break and I'll see you back for the Permian period. Bye.